Take two. So, we just got done doing this, determining whether something was a factor, yes or no. Okay? Obviously, we can determine if it's a factor by actually factoring it. But if we don't know how to factor, which we didn't know how to factor this guy, if we want to know if x plus 2 is a factor, we can just plug in negative 2 for x and see if we get 0. If we get 0, yes, it is a factor. If we don't, no, it's not. That's what we just got done doing. Okay? So, we kind of keep going on that. I'm just going to bring it back to numbers in a moment. Is 7 a factor of 1022? Nobody knows it off the top of their head, I'm guessing. So what are you going to do? You're going to divide, right? Okay, and I'm going to go old school here. All right? Okay? How do I do this? How many times 7 go to 10? 1.
Minus 7.
Wait, what?
What are you doing?
Yeah, minus 7.
Up top, you're 4, or you're 3 on mine.
Don't you subtract 7?
Yeah,
What
subtract
do you do with
7.
this one?
Leave it there.
Leave it there, and I put a
Subtract
3 on
7.
that too.
Subtract 7 from the 10.
Yeah.
Okay. So 1 times 7 is 7. So I put a 7 down there and I subtract it.
You get
Yeah,
a
and then you
3.
bring the 2
I
down.
get 3.
Drop 2.
Drop the
Drop
2.
on paper. 3
And now how many times is 7 going to 32?
7 goes into 32.
4 times.
4 times.
So minus
7 times 4 is
28.
28.
Subtract that.
Subtract it.
Bring down the 2. And then
Six.
that goes 6.
And it works perfectly.
0. Yes. Boom.
So is 7 a factor of 1022?
Yes.
Yeah.
Yes. Because there's what?
100. I don't know.
146. Didn't go in.
And there was not a what?
0.
There's not any.
There's not a remainder, right?
Oh, that's not true.
There's nothing left over. There's no remainders. There's no decimals, right? So is 7 a factor of 1022?
Yes.
Yes, because there's no remainder, right?
Correct.
Okay? So the reason I'm showing you this, okay, is to kind of show you another way to determine if something is a factor or not. Okay? And the way you can do that is you can actually divide polynomials. When I said is 7 a factor of 1022, all of you thought, well, I don't know, let's try dividing and see if it comes out evenly, see if it comes out without a remainder. I know you wouldn't have done long division, and some of you don't even do long division this way, okay, which is fine. Most of you would have grabbed a calculator and seen if there was a decimal or not, basically, okay. But the way you can determine if something is a factor or not is you can divide. So what I need to do now is actually show you how to divide polynomials. And you might say, why, when all you got to do is simply plug in the 0 and see if it equals 0 or not. Okay, I don't disagree, but what if I wanted to try and actually factor this completely?
Probably do grouping.
So, well, I can't do grouping because there's 5 terms.
Oh, yeah, I didn't
But
see
if I take this and I divide it by this, what is left over will only have 4 terms. And then maybe I can do it by grouping.
But do we have to do it that way?
So that's why I need to teach you division.
Okay.
Yes.
Really?
Okay?
It just
I
seems
need
so
to
much
teach you
harder.
division. So, I'm going to go ahead and I'm going to use this right here. Actually, I think I got it already, so.
Such a weird. So why would you want to do that if you already know how to use it?
Let's say I want to be able to factor it completely. Then I need to know how to divide. Okay? All right. So, it is entirely up to you if you want to write this long division down in your notes, because there is another method that a majority of you will use that is much faster. But I want to show you long division. Okay? I want to show you long division. So I'm actually going to take that polynomial that we had and divide it by x plus 2. Okay? And I'm going to do it using long division here to start. Here's how you do long division with polynomials. Okay, you'll be able to follow it. It's a lot of work, but you'll be able to follow it. Okay? So you know how in long division here you said 7 times what gives me 10, or as close to 10 as possible, right? 7 times what gets me to 10? Well, I can't get all the way to 10, but I can get close if I take 7 times 1, right? So here, I actually just ask myself, x times what gives me x to the 4th? X times what? So
X squared.
x times what gives me x to the 4th?
X squared times X squared.
No, x
X
times
X to the
what
third.
gives
X.
me x to the 4th.
X times X to the third.
That'd be x to the 3rd, right? So I'm going to put an x to the 3rd up here. Okay? So now let me go back. After you put a 1 up here, what did you actually do with that 1? You multiplied it by 7 and put that number right down here, right?
Yes.
1 times 7, you put it here and then you subtracted it.
Yeah.
Same process. I'm going to take this times what's out in front. What's this times what's out in front?
X to the 4th.
X to the 4th plus
2.
2x cubed, right? When I take this times what's in front, that's what I get.
Okay.
And now I'm going to subtract it. Just like I did with the 7 on the long division. So subtract, subtract.
The only thing left is
That's gone.
7.
8x cubed,
Oh, yeah, 8.
right?
Yeah, I was looking at 3.
And then I'm going to bring down the next term. And now I'm going to do the exact same process over and over and over again until I'm done. X times what gives me 8x cubed?
2x.
X goes into this how many times? X times what gives me 8x cubed? 8x squared. Then I'm going to take this times what's in front.
How did you get the 8? That because the X is just X. How did you
What's x times 8x squared?
8X cubed?
That's what I wanted it to equal. Right?
With the other one, it was like you couldn't get the exact answer.
What do you mean?
Like
X
you
times
could,
x
but
cubed was x to the 4th.
Yeah, but some I don't know. I don't know.
So I'm going to take this times what's in front. Take this times what's in front. What do you get? Come on, guys. I'm asking you to multiply these together. Let's go.
8X cubed.
8x cubed plus 16x squared. This is not difficult. This is like distributing. Okay? And then I subtract this, right? That's gone. That would be 5x squared. Bring down the next term. Okay. Do it all over again. X times what would equal 5x squared?
5X.
5x. Okay? Then I take this times what's in front. What do you get?
5X squared plus
Plus 10x. And then I'm going to, again, subtract, right?
so 4X
Negative 4x.
negative X.
Bring down my negative 8. And one last time. X times what gives me negative 4x?
Negative 4.
Negative 4. Take negative 4 times what's in front.
Negative 4X minus 8.
And then subtract that, which actually subtracting negatives would become plus positives, and I'd get a remainder of 0. So it goes into it evenly, which we knew it did already, right? From the previous video where we knew this was a factor. Okay? But this just proves that it goes into it evenly because I got a remainder of 0. So there is long division. Okay? Yeah. So when I take this and I divide it by x plus 2, there is my answer. Now unfortunately, I should have picked one that the answer can be factored further. But I tried to factor this one further. I just kind of made this one up or pound this one. It can't be factored any further. But the whole idea, the ones that I would give you will be factorable further by some sort of grouping method.
Would you?
You know, like where you group the first 2 terms together, pull out the greatest common factor, group the last 2 terms together, pull out the greatest common.
Can't you switch the order and have it be?
What's that?
Can't you switch the order and have it be factored? 5x and x cubed and then 8x squared.
But can't you?
Well, you wouldn't have the same factors.
Um,
Oh, yeah.
do you set those all to 0 now, or are they already all?
All I'm saying is I didn't pick a problem that was factorable any further.
I know.
Okay? If, ideally, this answer is going to be factorable even more by one of the methods that I taught you all last week. Okay? But I just pulled this one out because I knew this was a factor and I wanted to be a long problem, so I mean I didn't get one that's factorable, but you would be able to factor further. Okay? Now, I got 1 minute. I'm going to go real fast. Okay? Watch synthetic division. Okay? Everybody watch.
Should we write it down?
Okay? If x plus 2 is a factor, what was the 0?
-2.
-2. So I put a -2 in the box. Okay? I put a -2 in the box. Come on. Look at my coefficients. 1, 10, 21, 6, -8. I put those all out here to the right. 1, 10, 21, 6, -8. Okay? I take that first number, I drop it all the way below the line. And then I'm going to do the same process over and over again. Okay, watch the process. 1 times -2 is? -2. I'm going to put it right here and add those together and get 8. Then I'm going to repeat the process. 8 times -2 is? -16. Add them together and I get 5. 5 times -2 is? -10. Put it right here, add them together and I get -4. -4 times -2 is? 8. Add them together and I get 0. Okay? Look at these numbers. 1, 8, 5, -4. What I just showed you was synthetic division. It is a fast way to do long division. Okay? You're like, well, how do you know your answer then? Alright, well, let me ask you this. We started with x to the 4th, right? A 1x to the 4th, and then a 10x to the 3rd, and then a 21x squared, and so on, right? After you divide, guess what the highest power is going to be? X to the 3rd, because when you divide, it's going to go down by a power. So that's your 1x to the 3rd, that's your 8x squared, that's your 5x, and then that one doesn't have anything on it. That is your answer. 1x to the 3rd plus 8x squared plus 5x minus 4. So that is how you would get your answer. That's synthetic division. It's a lot faster than long division.
Will we go over that again?